Every time your phone waits on a cloud server, something small but real is lost. And for some problems, that wait is the whole problem. Most AI today works like this. Your device captures something, a voice command, a photo, a sensor reading, then ships that data to a distant server, waits for an answer, and gets it back. That round trip is called latency. For watching a video or getting directions, a few hundred milliseconds of delay is fine. You barely notice. But not every situation gives you that luxury. Imagine a self-driving car. It sees a child step into the road. If it has to ask a server in another city whether to brake, the answer arrives too late. The decision has to happen on the car itself, right now. That is the core idea behind edge computing. Instead of sending data to a faraway cloud, you process it on a device that is physically close, or even on the device itself. The cloud still exists, but the urgent work happens at the edge of the network. Modern smartphones already do this more than most people realize. When your phone recognizes your face to unlock, that comparison often runs entirely on a dedicated chip inside the phone, no internet required. That chip is doing real AI inference locally. It is not magic. It is a small, efficient neural network running on hardware designed specifically for that job. Now think about privacy. Every time your data travels to a cloud server, it passes through networks, gets stored somewhere, and becomes part of a system someone else controls. Edge computing changes that equation. If your medical wearable analyzes your heart rhythm locally and only sends a summary, or an alert, to your doctor, your raw biometric data never has to leave your wrist. The sensitive information stays with you. Factories use edge computing for similar reasons. A sensor on a machine can detect a problem and trigger a shutdown in milliseconds without waiting for a cloud round trip. Sending every sensor reading to the cloud would also cost a lot in bandwidth. Edge computing is not a replacement for the cloud. Heavy training of AI models, long-term storage, and complex coordination still make sense in large data centers. Edge handles the fast, local, sensitive stuff. The trade-off is real, though. Edge devices have limited power and memory compared to a data center. Fitting a capable AI model onto a small chip means making it smaller and less capable than its cloud version. Researchers are actively working on making models more efficient. Techniques like quantization and pruning. Shrink models without losing too much accuracy. How well that works depends heavily on the specific task. So the question is not really cloud versus edge. It is about matching the right tool to the problem. Speed and privacy push toward the edge. Scale and complexity pull toward the cloud. The interesting shift is that AI is no longer just something that lives in giant data centers. It is moving into the things around you. And understanding where the processing actually happens tells you a lot about what a system can and cannot do. If you want to go deeper, the question of how small you can make a capable AI. iModel is one of the more interesting open problems in the field right now, worth looking into.